Hello friends, today we are discussing the subject microprocessor, unit 2 bus cycle and system architecture, in which the microprocessor, the memory organization is one of the important topic. The memory banks, the memory banks, the memory is divided into four 8-bit wide memory banks of the memory. This 32-bit wide memory organization allows the bytes or double words of the memory data to be accessed directly. The 8036D is transferred up to the 32-bit wide number in a single memory cycle, whereas the early 8088 requires 4 cycles to accomplish the same task. Means 80386 can complete this task in a single memory cycle, whereas 8088 or 286 or 386 requires a more less memory cycles or more memory cycles. At 088 requires the 4 memory cycle to accomplish the same transfer of the 32-bit wide numbers, whereas 286 and 386 requires 2 cycles to complete the same transfer of the 32-bit wide numbers. Today, the data is more important, especially with a single precision floating point numbers that are 32-bit wide. High-level software normally uses a floating point number for the data storage. So, a 32-bit memory location speed the execution of high-level software when it is written to take the advantage of this wider memory. Each memory byte is numbered in hexadecimal as they were in the prior versions of the family. The difference is that the 386DS uses a 32-bit wide memory addresses with a memory byte numbers from a location 000H to the FFFH. The two memory banks in 8086, 286 and 386 systems are accessed via the BLE and a BHE, and in the 386 DX, the memory banks are accessed via four bank enable signals from BE0 to BE3. It also allows a word to be addressed when two bank enable signals are activated. In most systems, a word is addressed in a bank 0 and bank 1, or in a bank 2 or and in a bank 3. Memory location 00H is in a bank 0, and memory location 001H is in a bank 1, and memory location 002H in a bank 2, and a memory location 003H in a bank 3. The 386DX does not contain certain address connections A0 and A1 because this has been divided encoded as a bank enabled signals. Likewise, a 386DS does not contain the A0 address pin because it is encoded in a BLE and BHE signal. The 80386EX address data either enter in a two banks for the 16-bit wide memory if a BS8 is 1 as a 8-bit or BS8 is equal to 0. The memory is divided into the four 8-bit wide memory bank allows byte double words of the memory data to be accessed directly. Transfer up to the 32-bit wide number in a single memory cycle. Memory byte numbers from the location 00 to FFH. So the four bus enable signals are shown here, and what is the condition or which operation they will perform when a data bit is set. When all the B signals are set as a 1, no operation will be performed. When only the B0 is 0 and all the B1, 2, 3 are active high, at that time bank 0 is selected for the 8-bit. When a B1 is 0 and B0, B2 and B3 are active high, that means a bank 1 is selected with for the 8-bit. When a B2 is 0 and B1, B0 and B3 is active high, at that time B2 is selected for the 8 bit. When a B3 is 0 and B2, B1 and B0 is 1, that is a active high. That means a bank 3 for the 8 bit is selected. B1 and B0 are 0 and B3 and B2 are active high. That means a 1. At that time, bank 0 and bank 1 are selected for the 16 bit. When a B2 and B1 are 0 and B0 and a B1 is B3 is 1, at that time bank 1 and 2 is active for the 16 bit. B2 is 0 and B3 is 0 and B1 is 1 and B0 is 0. At that time B2 and 3 is active for the 16 bit. B2, B1 and B0 is 0 and B3 is 1. Bank 0, 1, 2 are active for the 23 4 bits. The same thing is that when all the B signals, bus enable signals are 0, at that time all the banks 0, 1, 2, 3 are active for the 32 bit. Now we will come to the next point, that is a memory read and a write cycle. Okay, in this memory read and a write cycle, this is a memory read and write cycle with a no wait state. Okay, in which cycle 1 is not for a non-pipeline, cycle 2 for the non-pipeline read, cycle 1 for a non-pipeline write, cycle 2 for the non-pipeline read, cycle 3 for the non-pipeline write, and then the ideal state, cycle 4 is a for non-pipeline read. So in this way, the process goes on. A clock signal is there, bus enable signals and address signals A2 to A31 and B16 signal is there, a ready and a log and D0 data bus, a 32-bit data bus is used here. A memory unit generally supports the two fundamental operations, that is read and a write operations. A read operation reads a previously stored data and a write operation stores a value in a memory. Memory read and a write bus cycles. The following steps have to be followed in a typical read cycle. Place the address of the location to be read on a address bus. Second step is to activate the memory read cycle and control signal on the central control bus. The step 3 is wait for a memory to retrieve the data from the address location. Step 4 is to read the data from the data bus. Step 5 is to drop the memory read control signals to terminate the read cycle. Okay, this is a typical read cycles. So well steps to be followed in a typical write cycle. Place the address of the location to be written on a address bus. Place the data to be written on a data bus. Activate the memory write control signals to control the bus. Wait for the memory to store a data at the address location. Drop the memory write control signals to terminate the write cycle. In which the T1 is the first clock of the non-pipeline bus cycle. That is the Intel Thread 6 DX drivers now asserts a ADS active low signal. A T2, a subsequent clock of the bus cycle with a no operation, that is a NA active low has not sampled asserted in a current bus cycle. TI, it is an ideal state. TH, it is a hold acknowledged state. Intel Thread 6 DS asserts the hold A. The fastest bus cycle consists of the two states T1 and T2. Now the memory read and a write cycle with a wait state. The operations to be followed in a write cycle is to place the address of the location to be read on a address. Place the data to be written on a data bus. Activate the memory write control signal on the control bus. Wait for the memory to store the data at the data address location. Drop the memory with a write control signal to terminate the write signal. This is all about a memory read and a write cycle. Okay. Thank you for watching. Thank you for watching.